Okay, so we're now going to do a couple of circuits. What you're going to see is I like to use colors because the biggest thing in circuits grade 11s is you forget what goes with what. Okay, so this is also from the worksheet you've got. So we're looking at question 7 and they tell you assume the conductors and battery in the circuit shown have negligible resistance. In other words, the resistance can be ignored. So what we're going to do is I'm going to choose a color and I start, the current goes through here, goes through there, goes through there, gets to this point. It's now going to split. Okay, we'll deal with that in a second. Once it gets to the other side, it all comes back together and around it goes. So that's the total current because it's the current that's coming out of the battery. So that's the total current in the circuit. The current split though. So some of the current went through the 6 ohm. Okay. Now, if both resistors were of equal value, then I'd use the same color, but they're not. The other one is the 3 ohm. So now I know where my parallel section is. So that means I know where the current divides and I know where voltage stays the same. So the first thing they ask me for is the current flowing through the ammeter. It's the blue line. That's the total current. What we would normally try and do is use total resistance. That should be your first point of call. The problem is this. I don't know the total resistance because I don't have R. But this 1 ohm resistor also has the blue. So because the ammeter and the 1 ohm resistor are both going through blue, it's in series, they both have the same amount of current going through it. For that 1 ohm resistor, I know enough to find current. I know the potential difference and I know the resistance. So if I look at the 1 ohm resistor, okay, I can say, well, 1 equals 3 over I, and my I is 3 amperes. So I'm going to put 3 amperes there because now I know what it is. Okay? Pretty straightforward. Now they want the total resistance in the circuit. Once again, I can't do a simple addition, but I know what the total current is. I know what the total potential difference is. That means I can find the total resistance because resistance total is V total over I. Okay? So V total is 12, we were given that, and I is 3. So now my total resistance is 4. It doesn't matter that I didn't know what R was. Okay? They want what R is. Okay, so you've got to remember that we knew that this was, if we go back here, let's just look, this was 3 amperes. And I know that R total, because we worked it on the last page, was 4 ohms. So I'm going to keep that. Okay? They want R. But now this is where you tend to do silly things mathematically. Because you realize that you need to put all of them together, but you cannot do this in one step. You have to calculate the one that is R parallel on its own. So R parallel would be 1 over R1 plus 1 over R2. So it's going to be 1 over 6 plus 1 over 3. Okay, which gives me 3 over 6. Your calculators will give you a half. And you have to then turn that upside down. Okay, so you've got to invert it. So R parallel is 2 ohms. Straightforward. My total resistance is going to be the 1 ohm plus the parallel plus R because they're in series with each other. I know the total is 4. The 1 ohm is 1. R parallel is 2. And R is, well, what we're looking for. That means R is 1 ohm. That's pretty straightforward. And we also know now that this is 2. So I'm actually going to put this in here. So this is 2. Of course, you have the same picture with you the whole time, so you don't have to keep doing this. Alright, and this was 4 ohms. And we just worked this out to be 1 ohm. Then they ask us, what is the potential difference across, PD means potential difference. Okay. V. That's what they want. Well, I know the resistance in parallel. I know the current. So that's what I'm going to use. RP equals VP over I. So 2 equals VP over 3. My potential difference is 6 volts. Now we get to the fun questions. Okay. They want the current in the 6 ohm resistor. Okay, just the 6 ohm resistor. So we have to remember that the potential difference over the 6 ohm resistor is 6 volts. Our 6 ohms is Vp over 1, right? The current in the 6 ohms. We know that the resistance is 6, the potential was 6, therefore the current is 1. Now, you need to do worksheet questions 8, 10, and 12. Obviously, the more you do, the better. All the answers to those are on Teams. Okay, this is one of those things where the more you do, the better you get at it.